Assalamualaikum. I hope everyone have a good day today. These are my fellow group mates and let's move to our presentation. So, what is a medical diathermy? From the term itself, it has their own explanation. From the word diathermy, dia itself means truth and thermy means heat or temperature. So, the whole medical thermy explanation is described as the application of shortwave or microwave electromagnetic energy to produce heat and other physiological changes within the tissue. So just now, I explained to you about medical diathermy generally, but for our presentation, we specify in shortwave diathermy SWD. So what is SWD? It is an electrotherapeutic modality that delivers high-frequency electromagnetic energy to biological tissues, generating either thermal or non-thermal physiological effects depending on the treatment parameters. The pattern of heat produced depends on three main points, which is type of SWD unit, amount of frequency used, and also water content of the tissue. The shortwave diathermy SWD current frequency used is around 10 to 100 MHz. And for information, the shortest radio frequency wave is used in therapeutic diathermy. And 27.12 MHz with wavelength of 11 meters is most commonly used in SWD, who is suitable for SWD treatment. So SWD treatment is suitable for persons who suffer from inflammatory conditions, soft tissue injuries, muscle spasms, chronic pain, and also joint stiffness. There are two modes in SWD. The first one is continuous shortwave diathermy, CSWD for thermal effects, and the next one is pulse shortwave diathermy, PSWD for non-thermal effects. I will pass the next presentation to my friend.
How radio wave induce heating? Radio wave induce heating through a process called dielectric heating. Dielectric heating is a process that heat non-conducting materials such as wood, plastic, and ceramic by subjecting them to high-frequency electromagnetic radiation or alternating electric field. The dielectric material, which to be heat, is placed between two conducting electrodes, which alternating voltage of high frequency is applied, and it will form a giant capacitor. The applied electric field exerts a force on a molecule of the material, so a molecule that have dipole moment such as water attempt to flip back and forth to align with the alternating field. The molecular motion will increase the collision between particles, so this collision will convert the electromagnetic energy into thermal energy, which is heat.
Let me introduce the parts of a shortwave diathermy circuit and its functions in generating useful radio waves. From the diagram, the power supply functions to convert the standard wall outlet electricity into a high voltage current to power the machine. The electricity then flows into a high-frequency generator that produces the initial weak high-frequency electrical oscillations, typically at the standard medical frequency of 27.12 MHz. Next, the amplifier takes the weak high-frequency signals from the generator and increases the amplitude significantly to ensure the energy is powerful enough to penetrate deep human tissue. The oscillator coil functions as a transmitter and creates a rapidly alternating magnetic field. A resonator coil placed directly opposite the oscillator coil catches the alternating magnetic field through electromagnetic induction, thus transferring the radio frequency from the machine circuit into the patient circuit. A variable capacitor's role is to enable tuning of internal frequency to match the patient's impedance in order to ensure maximum energy transfer and efficiency. Lastly, electrodes are the physical pads or plates applied to the patient, directing the high-frequency electromagnetic field into target area. As radio waves penetrate the tissues, they pass right through the skin and superficial fat layers. If using capacitive pads, heat is allowed to accumulate in fat layers as fat resists electrical currents, or in this case, electrical field. It then heats up like a resistor. Another way, by using an induction drum, the waves pass completely through the fat without hitting it, going deeper into the body. Once these waves reach deep tissues like muscles, joints, or tendons, molecular friction occurs. The alternating radio waves change direction millions of times per second. This forces the polarized molecules in our body to rapidly rotate and vibrate back and forth. This intense atomic friction generates deep internal heat rather than from the surface heat from manual
Why medical diathermy is better than contact heating? Medical diathermy is considered better than contact heating because it can generate heat deep within the body tissue using the high-frequency radio wave. Firstly, it helps to improve the blood circulation. The heat will cause vasodilation, which means the blood vessels will expand and allow more blood to flow through the treated area. This increases the supply of oxygen and nutrients to the tissues, helping to speed up the healing process while reducing the muscle soreness and stiffness. Secondly, diathermy provides a greater pain relief. The heat will help to relax tense muscles and reduce the pressure on surrounding nerve. It also will decrease the sensitivity of pain receptor, making pain signals less noticeable to the brain. As a result, patients experience temporary pain relief and greater comfort during the movement. Lastly, diathermy is a non-contact treatment. Unlike the contact heating, it does not require direct contact with the patient's skin. The radio wave travels through the air and penetrate the body tissue, where the energy is converted into heat. This also makes it especially for patients with sensitive, painful, or injured area, as it reduces the risk of skin irritation while providing effective deep tissue heating. So, in conclusion, medical diathermy is more effective than the contact heating because it will improve blood circulation, provide a better pain relief, and offers a comfortable non-contact treatment method. Although medical diathermy has many benefits, it is generally not recommended for patients with tumors, especially malignant or cancerous tumor. It is because, firstly, diathermy can increase the blood supply to the tumor. Since the treatment will improve the blood circulation, more oxygen and nutrients are delivered to the affected area. This may potentially support the growth or spread of the cancer cells. Secondly, diathermy may interfere with the cancer treatment. If the patient is undergoing the radiation therapy or chemotherapy, the tissues are often sensitive and weakened. Applying the deep heat can increase pain, swelling, redness, and discomfort, making the tissue more vulnerable to the heat damage. Lastly, diathermy can cause unwanted heating of tumor tissue. Excessive heat may damage surrounding the healthy tissue and increase the inflammation. It can also cause discomfort or pain because the response of tumor tissue to the deep heating is difficult to predict. Therefore, medical diathermy should be avoided in patients with malignant tumors unless specifically recommended and monitored by the healthcare
Next,
professional.
I will present ways to improve diathermy heating application. First, standardization of research protocol. Use comparable treatment settings and the exact same outcome measurement tools. This consistency will allow you to compare data accurately and draw strong conclusions. Second, check cost effectiveness. It will depend on economic values. Need to prove the physical benefit the patient gets actually justify the financial cost and time spent on the treatment compared to the cheaper alternative, for example, hard pack. And lastly is study long-term effect. Look at how the patient feels after the treatment. Need to follow up with the patient over months or years to evaluate if the pain comes back. In conclusion, the study of electromagnetic wave helps in invent new ways to help patients with their health by using diathermy heating application. This method has more advantage and is more effective than contact heating. At the same time, medical diathermy has its own risks such as increased blood supply to the tumor, interfering with cancer treatment, and unwanted heating of tumor tissue. Many improvements need to be made such as standardization of research protocol, check cost effectiveness, and study long-term effect to make this application more efficient and useful. That's all from us. Thank you and bye!